Okay, we got pre-calculus notes here, and Taylor is absent today. Taylor, we miss you a lot. Angie says she enjoys the extra elbow space back there. But other than that, we hope you feel better. Could tell you weren't feeling the best yesterday. Strep throat, make sure you eat lots of ice cream, right? That's kind of the deal. Ice cream, strep throat. All right. Exponential. Exponential functions, okay? That's what we want to look at right now, okay? And an exponential function is of this form, y equals a to the x power, okay? So I'm going to make a table of a bunch of different functions, and we're going to look at their behavior. We're going to plug in values of -3, -2, -1, 0, 2, 3, 4. Go all the way up to 6. Do you know what the first one looks like? Y equals 2x. What is that? If I were to graph that, what does it look like? The line with a slope of 2 and it passes through a y-intercept of 0. There you go. Okay, that's what I got. So we could graph that. Y equals x squared. What does that look like? Parabola centered at 0, 0. Okay? So we know what those first two look like. We don't know what the last one looks like, but we're going to look at a bunch of table values and see if we can kind of make a prediction about how it looks so we can learn from that. So if x is -3, let's just fill out the first one here. Okay? If x is -3, what is the y value for the first one? If x is -2, -1. If x is 0, we got 0. Plug in 1, you get 2, you get 3, you get 4, you get 5, you get 10, and 6, you get 12. Do you notice the pattern? Goes up by 2 because the slope is 2. That's the definition of slope. Constant change in the x corresponds with constant change in the y. That's what we have. You can see it laid out right there in front of you. Any questions how we generated those values? Piece of cake. All right, let's do this one then. Okay, y equals x squared. I'm going to take the x value and I'm going to square it. If you plug in -3, what do you get? -2, -1, 0, 1, 2, 3, 4, 5, and 6 is 36. Oh boy. Does that graph ever go below the x-axis? No. That graph is never negative, is it? Okay? Look at the positive values. Right here, the positive values. Okay? You tell me, which graph grows more quickly? Which graph gets bigger? Okay? The first one or the second one? Second one, you can look here. You got values like 4 and 4. Oh, they're at the same spot. And then you go 6, 9, 8, 16, 10, 25, 12, 36. You can see, obviously, the x squared function is getting significantly bigger. Okay? Any surprise there? Let's look at the next one. Y equals 2 to the x. So I got to plug that in. So like y equals 2 to the -3rd. What is 2 to the -3rd? Oh, no. Good try. I was trying to figure out what you were doing, and I was now I think I know. Excellent effort. So 2 to the -3rd is the same as 1 over 2 to the 3rd. What's 1 over 2 to the 3rd? 1/8. Very good. Which is 0.125. As I said, excellent effort. Excellent effort. What's 2 to the -2? 1 over 4. What's 2 to the -1? What is anything to the 0 power? 1. 2 to the 1? 2 to the 1 is 2. 2 to the 2 is 2 to the 3. 2 to the 4. 2 to the 5. And 2 to the 6. Interesting. Interesting, interesting, interesting. Let's see what the behavior of this thing looks like. Let's graph this. Look at these values right here. If we kept on plugging in negative values like negative 10, negative 20, would they ever go below the x-axis? They would never get negative, would they? And they're always getting smaller, closer to, and if it's closer to the x-axis, it's closer to a value of 0. These are getting really, really close to 0. So these functions always have what we call a horizontal asymptote. We can either call it an asymptote or an asymptote. Okay? Either way is fine. And in this situation, it's not always the case, but in this situation, the horizontal asymptote is the x-axis, or the equation y is equal to 0. And an asymptote is a line, not actually part of the graph, but it's a line that the graph approaches, but never actually touches. It's kind of like a guide for drawing the graph. Now here's another interesting point. Look at my function, a to the x. If you take anything to the 0 power, what do you get? 1. So we know that this graph crosses through 0, 1. It starts here. It follows really close to that horizontal asymptote. Then it starts to go up through 1. What happens after that? It goes up. Does it go up more quickly or less quickly than the other graphs? Oh yeah. You can see already at 6 you're at 64. Whereas these are only at 12 and 36. So exponential functions, they jump up. If anybody ever uses that term, exponentially, you know what I mean? My love for mathematics has increased exponentially. That's this idea of, wow, it grew really quick. Okay? Or my hate for lutefisk. Anybody eat lutefisk? Ugh. Oh, you've eaten lutefisk. Oh, wow. Do you like it? Wow, that's amazing. I've only met a few people. Really? Wow. Good for you. Good for you. Good for you. Good for you. We'll have to have some in class sometime. So anyway, this is what it looks like. Is that a graph you can understand? Now, that's if, so A is my base, that's if A is greater than 1. But let's suppose that A isn't bigger than 1. Let's say it's between the values of 0 and 1. It's a fraction. Then the graph looks like that. Now, I need you to keep this in your brain. The last thing I need you to keep in your brain. Do those graphs look similar? They're just reflected over the y-axis. That's a horizontal or vertical reflection. Horizontal reflection. Okay? They are a horizontal reflection of each other. Flip it over. Let's go through some problems. What time we get out of here? Anybody know? I feel like I'm up 14? Oh, so I got time. Awesome. All right. So y equals 4 to the x. The first thing we do is we identify the horizontal asymptote. And in this case, it's going to be y equals 0. Will it ever not be y equals 0? Yes, but that's after we have a transformation. Nothing different is happening with this function other than we have a value of 4 for the base. And that does not change the fact that it has a horizontal asymptote at 0. Question. So if you look at your table values, so this is kind of how we figured that out. I think it's this one. There we go. So as we have negative values like -1, -2, -3, you can see the output values, 1/2, 1/4, 1/8, they're becoming very, very small. The next will be 1/16, then 1/32. They're getting really close to a value of 0. They will never actually touch 0, but they'll get really close. And that's why we have the 0. So we've got a horizontal asymptote at y equals 0. I know it's going to cross through the y-axis at what value? 1. Very good. And it starts right there, and it starts to then head up, and it gets, pretty big pretty quickly. And that's the graph. I'm going to put 2 more points on the graph just so we understand the growth of the graph. Let's say I plugged in a value of 1. If you plugged in 1 to this function, what would you get as an output? So 1, 4 is a coordinate on that graph. Let's look at this one, 2. If you plugged in 2, what would you get? So 2, 16 is a coordinate on that graph. Now, I know I haven't plotted those to scale. I know that. But I've at least listed them to understand how I'm generating those points. Okay. So your assignment might ask you to do that, might not. But if it does, you can make sure that you include that. How is the next graph different? Yeah, it's a fraction, so it starts up and finishes down like that. So we're still going to have the same horizontal asymptote. The horizontal asymptote is y is equal to 0. That's what I've got. It's going to cross through that spot on the y-axis until there's a transformation like this. That would be different. So I'm going to draw the graph now. It's going to start up and it will finish down like that. I don't like that. I'm going to redraw mine. I'm sorry. Do these two graphs look similar? They're simply reflected over the y-axis, right? Watch. Can I show you something? This is the connection I want you guys to make. We have 2 graphs. Y equals 1 over 4 to the x. And we have y equals 4 to the x. And you guys tell me that those are very similar, right? Watch this. Would you guys agree that y equals 1 over 4 to the x is the same as y equals 4 to the -1 to the x? 1 over 4 can be written as 4 to the -1, right? Same stuff. If I have an exponent to an exponent, what do? I multiply. So these are all the same, aren't they? Doesn't that look similar to that? The only difference? You got the negative. And a negative on the x reflects it over the y-axis. So that's why they are reflections of each other the way that they are. Okay? That's the last connection piece. Now we just plow through the problems. Y equals 2 to the x. Is it going to look like the A or B? It's going to look like A. And we have a horizontal asymptote. That's still y equals 0. Nothing has changed there. Passes through 1 on the y-axis. Starts down. Finishes up. Because you have the 2. If you had a 1/2, it would start up and finish down. Okay. Let's pick out 2 more points on here. If you plug in 1, what do you get for an output value? If you plug in 2, what do you get for an output? 4. So which one's growing more quickly, letter A or letter C? Letter A is, you see 216, for C you see 24. So you can see that this one's definitely getting bigger. Got A through C? Then we're going to do the next 3. That'll be the extent of our lesson. We've got 6 minutes. We can do it. Y equals negative 8 to the x. How is this one different? Negative in front. If you've got a negative in front, it flips it over the x-axis. It's a vertical reflection. So instead of going like that, it's going to go like that. Just a reflection over the x-axis. That's all that's going to happen. So we still have our horizontal asymptote of y is equal to 0. Okay? What point did this pass through before it had the negative on it? 0, 1. So now it's going to pass through 0, negative 1. Yeah, it's just reflected over. And you could just plug in a point to check that. I mean, if I plugged in 0, 8 to the 0 is 1, then make it negative, negative 1. It's going to work out. How is E different? When you do the, very good, when you do minus 4, what does it do to the whole graph? Shifts it down 4 units. So this is a, down 4 is the shift that you have. So it's going to look the same as what 3 to the x would be, just everything's going to be moved down 4. Well, if I move everything down 4, does that change the horizontal asymptote? It does. The horizontal asymptote, instead of being y equals 0, will now be y equals negative 4. So I should draw that right down here. It used to pass through 0, 1, but if it's shifted down 4 units, it's now going to pass through, as Scott said, 0, negative 3. And because it's a 3, will I start down and finish up, or will I start up and finish down? Start down and finish up. There you go. Always draw the horizontal asymptote. Always, 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 always. When we graph secant and cosecant, when we graph conic sections, hyperbolas, you're going to have to draw asymptotes all the time. Asymptotes are extremely important parts of the graph. Okay, last one. I got 4 minutes. Y equals 2/3 x minus 2 plus 1. So there's some transformations that take place here. We're just going to draw it out. I'm going to start by drawing the parent function. So I'm just going to draw y equals 2 over 3 to the x power. Forget about the transformations. I'm just going to draw the parent one so we can see. The parent one would have a horizontal asymptote just like this, and it would pass through 0, 1. If you had y equals 2/3 to the x, is that going to start up and finish down, or start down and finish up? Start up, finish down, because it's less than 1 but bigger than 0. So I start up and I finish down. That's what the graph wants to look like, right there. Okay? That's what it wants to look like. But we have these transformations to it. So let's think about the transformations. What does the plus 1 do to it? Up 1. What does the x minus 2 do to it? 2 to the right. So if I move up 1, does that change the horizontal asymptote? Yeah. So the horizontal asymptote is going to be y equals positive 1. That will be my new asymptote. Question? Yeah. Yep. And then, right 2 up 1, here's what I have to do. I've got to take this point that it passes through, this 0, 1 spot, I have to move it to the right 2, and I got to move it up 1. So its new location will be 2, 2. And so now the graph will pass through there. We haven't figured out where it's going to cross the y-axis necessarily. We could do that by simply plugging in 0, but right now that's the view of the graph. What do you think? No, you could draw the first one, say that's my parent function. No. Did you have a question, Carissa? That was it? Okay. All right, we made it through. The other hours we ran out. There you go. 1 through 3 and 7 and 8. That's it. I'll try to run off packets tonight. Okay? But this is your last test, guys. You know, Chapter 4 is our last test in a final exam. You have 4 college credits to your name for mathematics. For some of you, your career in mathematics could be over with. You could say, you know, that's all I'll need in college. So this is really good stuff, okay? So we're almost to the end of that first portion. You guys have been troopers. This is the quickest we've gone through the course since I've been here. And it's going to pay off because we're going to be able to review for the final. You're going to get great scores on the final. And we'll have some time at the end where we can cover the material I've always wanted to get to that never got to get to. So, oh, trig is definitely more difficult. But it's slower. We have more time to get through the trig material. Oh yeah, oh yeah. But we take baby steps next semester. This year we take bigger steps. Next semester we take smaller steps. The calculus is even more difficult, but we take even smaller steps. Okay? I don't know. What do you want, Sini? Okay, so bye-bye, Taylor. We miss you. We hope you feel better. Eat a bowl of ice cream. Go take a nap.